right, greetings everyone. It's Mr. Shajai again, and welcome to Back to Basics. What is it that we are looking at now? We are looking at our Euclidean geometry, and this is going to be our November again 2023 paper, and this is going to be question 11. The province is going to be Gauteng. Right now, let's just go straight to it. They say DE is a tangent to what? To a larger circle, right? As soon as I see the word tangent, I already think of the three theorems, which is my tan chord, right? Which is my tan chord theorem, which my tan perpendicular to radius, which is going to my tan from the same point, right? Tangent drawn from the same point. Oh, it's okay. So these are the three things that I think of as soon as I see the word tangent. Now they say DH is a tangent. Again, I think of the three theorems. Now to the smaller cycle, they say now your chord HK is extended to meet the larger cycle at E, and then F and K are point of intersection between the two circles, with FK produced to D. Your GK is a chord of your small circle with the circle with FE, a chord of the larger circle, your HF, GH, and your GF join. Okay, I know this particular statement, it basically, it is, somehow just, a little bit too much, but just ensure that you take note of these important things that they are going to at least provide you a guide on what you are required to do here. How to get. So now let's go straight to it and see in terms of what is that you can do now from here. So if we look at the first question, they say complete the following statement. So now they are saying angle D3. Where is your angle D3? This is going to be this particular angle, right? Now, what is it that you can take from D3? Now we are saying your D3 can be equals to what? Now, your D3 can be equals to your what? Remember that your D3, if you can look at this particular triangle here, right? If you look at this triangle here, this red triangle that I've just highlighted here, your triangle, what? If you can say in triangle D what? DHE, right? In triangle DHE. What is it that you can do now? Your angle D3 is going to be equals what? Your angle D3 is going to be an exterior angle of what? An exterior angle of your triangle. So which means your angle D3 is going to be equals to H1 plus your angle E1. What is going to be that? This is going to be as the exterior angle of your triangle. Are we together? So yes, that's going to be the complete statement of that one. Now, 11.2, they say prove that DEFH is your cyclic quadrilateral. All right. So now, how do I prove that this is your cyclic quadrilateral? So now, for me to prove cyclic quadrilateral, I need to at least prove that the opposite angles are supplementary, or I need to also prove that your exterior angle of your cyclic quad is equal to the interior opposite angle. Altogether. So these are two theorems that I need to prove every time when I have to deal with cyclic quadrilateral. Now, so from here, let's see. Your D3. Now let's start again. Now if I can start here, already I know that my angle D3. I know that my angle D3 is equals to what? Is equals to H1 plus what? Plus E1. The reason it is given actually, or rather the reason is given above or proven, right? The reason is already proven. Now, what else I know? I also know that if I can look at my angle H1, right? My angle H1 is going to be equals to what? Is going to be equals to F2. Why? If you can look at your angle H1 in the small triangle, right? If let's say I connect this line and I connect this line, right? And we are only focusing in what? In triangle what? Let's say you are focusing only in triangle HKF. HKF, right? This triangle HKF, you would see that your angle H1 here is going to be equal to your angle F2, right? Because of what? Tan chord theorem. Okay, so that's going to be the first thing. Secondly, what is it that you can also take from here? But I want you to take this also, or rather, let's just use the word. And now, if you can look at angle E1, right? My angle E1 is going to be equals to my angle what? My angle E1 is also going to be equals to what? My angle F1. It's going to be the same reason, because if you can also focus on triangle KFE, right? Can you see that this angle is your tangent, and if this is your triangle, your KFE, then this is going to be what? The angle that is subtended by this particular chord, right? So this is still going to be your tan chord theorem, right? So now if this is going to be your tan chord theorem, what else now can you note here? So from this particular conclusion, right? So which means now I can conclude that since my angle D3, my angle T3 is going to be equals to angle F1, right? Angle F1 plus what? Plus angle F2. Why? Because angle F1, remember that angle F1 was equals to H1, and my angle what? My angle, or rather my angle F2 was equals to H1, and my angle what? My angle E2, my angle F, or rather E1 was equals to my F1 altogether. So which means from this conclusion, if this angle here is equals to this, and this one is equals to this one, which means your your H1 and also your E1 are also going to be the same as F1 and also your F2, right? So which gives us the conclusion of our D3. And now that we have proven that our angle D3 is going to be the same as what? Angle F1 and F2, then this supports that the exterior angle of your what? Of your cyclic quadrilateral is going to be equals to the interior opposite angle altogether. So which means now we are going to then conclude that, in triangle, therefore you can conclude that your DEFH, what is your cyclic, this is our cyclic quad, right? Why is this going to be your cyclic quad? Now, this is because of what? This is going to be because of your exterior angle, which is going to be equal to the opposite interior angle altogether. So basically, that's going to be that. Now, so you are going to just go straight forward and get your 4 marks from them. Now, what is it that now I want you to look at? They want us to also prove that your DF bisect HFE, right? How can we prove that? Let's just make up our space here. So now in order for us to prove that, what is it that we can take from here? So what does this mean? Firstly, if they want us to prove that your DF, this is the DF, it bisects what? It bisects HFE. It bisects HFE. So basically, they want us to prove that F1 is equals to F2 altogether. Now, so what is it that you're going to prove from here? You can literally just start by saying, look, my angle H1 is going to be equals to what? My angle H1 is going to be equals to my angle what? F1, right? This exterior angle here, this angle here is going to be equals to what? Is going to be equals to your F1. Isn't it so? Right? Your H1 is going to be equals to your F2 rather, right? Because of tan chord. Because if you can look at these and this angle, this is going to be what? Tan chord theorem. Now, what else now are you going to then do from here? You are going to say, if I can also look at my angle, what? My angle H1. If I can say also my angle H1 is equals to my angle F1. Now, why am I saying that? My H1 is equals to my angle what? My angle H1, this is my angle H1 is equals to my what? My F1. These are going to be subtended by the same segment, which is DE, right? So if you can look at these angles, these are going to be the angles that forms a butterfly, right? So if I can just draw from here, can you see that your F1 here, right? And also your H1 here, right? Your H1 here, these two angles are subtended by the what? By the same segment, which is your DE altogether. So which means this, they form a butterfly angles, which are from what? This is from theorem what? This is from theorem 4, if I'm not mistaken, altogether. So which means now, if that's the case, this is going to be the angles in the what? In the same segment, right? So these are going to be angles in the same segment. So these are going to be equal. So now if those are equal, then you can then conclude that both of them, your F1 is going to be equal to your F2 because both are equal to what? Both are equal to H1 altogether. So that's going to be your conclusion on that. And now what else now are you then going to be having here? So basically that is going to be the question that you are going to be having. In question 11.4, what is that we are required to prove here? They want us to prove that K1 is equals to E1. Are we together? Now they say if K1 is equals to E1, prove that your GK is a tangent to the larger circle at what? At K, right? Altogether. So basically that's that. And I want you to take note that this particular question is actually 7 marks, right? Now, so what is it that you are going to do now? Firstly here, now you are going to start here. Now, if we can start here, for an example, I want you to take note that, remember, we've already proven that your DEFH is going to what? It is going to be your cyclic quadrilateral, right? So now I want you to start here in attempting this question. You are going to say, look, if I can start with my angle, what? If I can start with your H3, if I can say H3 plus H4 is going to be equal to what? E1 plus what? Plus E2, right? Now what is that? H3 plus H4, right? H 3 plus H4 ways. This H3 plus H4 is going to be, look at me here, right? H3 plus H4 is going to be equals to what? Your E1 plus E2. This is going to what? An exterior angle of your cyclic quad. An exterior angle of your what? This is going to be an exterior angle of your what? Of your cyclic quad. Now, so now what else can you now also take note of from them? Now you can also take note that if, let's say, you're looking at your angle H4, right? If you look at your angle H4, your angle H4 here is going to be close to your angle K1, right? Your H4 is going to be close to your angle K1. What is going to be the reason? That because this is going to be a tangent, right? This, if you are looking at triangle HKG, can you see that now your H4 is going to be the tangent from this particular triangle altogether? So this is going to be your tan chord theorem, right? This is going to be your tan chord theorem. And what else you can take note of here? Now, I want you to also check if, let's say, we look at our H3 now, this particular angle is going to be close to our K2. Where is the K2? The K2 is here, right? It's going to be close to our K2. What is going to be the reason here? Now look, these angles are subtended by the same segment. If you can just draw the butterfly angles here, right, you'll realize that these particular here, can you see that this makes a butterfly, right? So these are going to be the butterfly angles. So therefore, which means these, your angle H3 is going to cause your K2, right? Angles in the same, right? Angles in the same segment. Okay, so that's going to be the reason for that, right? Now, what else now can you take note of? Now from here, let's see. Now, so which means now, if we have proven that H3 is equals to K2 and H4 is equals to K1. So from these particular conclusions, I can replace the H4 and H3 by what? By K1 and K2, which means I can say my K1 plus my K2 is going to be equals to my E1 plus my what? My E2 altogether, right? And then now, I can also conclude that from here, look, my angle K1 is going to be close to my angle E1, right? My angle K1 here is going to be close to my angle E1. What is going to be the reason for that? K1 is going to be close to E1. Why are we saying that A1 is equals to K1? That is given, right? Remember, this one is a given. And then now, from here, what is it that I can also conclude? I can also then conclude that my K2 is going to be equals to what? Is going to be equals to now E2. Are we together? right? Because if I prove that my K1 is equals to, if I prove that this angle here, now if I've already proven that this angle here, the K1 here is equals to what? Is equals to E1. So then I can also conclude that this angle is also going to be equals to this one, right? So if these angles are equal to each other, right? So if this, your what? If your E2 and also your what? Your K2 are equal to each other, what is it that I can also conclude then? I can now conclude that my KF is a what? Is a tangent. Why? Why are we saying that? I can also conclude that this is a tangent because from the tangent, remember, this is going to be your tan-chord theorem. Altogether, this is meant to be a tan-chord theorem. So which means this is going to be the converse of tan-chord theorem. Tan-chord theorem, right? So then that's going to my conclusions that I can draw from this particular question altogether. So this is how you are required to answer all these particular questions. Hopefully that this makes sense to you now. And thank you very much.